Hey, hey everybody. So we are back. I am running a little bit late today, and I will actually explain why. Um, so for people who are just seeing me for the first time, my name is Aaron. I am a data scientist currently in government, and I do these currently twice weekly streams where I get on stream and I try to study, and I do this out in the open like this to try to keep myself accountable. Because otherwise it's going to be super easy to not study. And the reason why I'm doing these things is to basically review skills and stuff that I've picked up, or not picked up, but like maybe I'm not using in my day-to-day job, which is unfortunate. And I want to do these things to, be a better data scientist, be a better statistician, et cetera, et cetera. So currently, I am trying to relearn, actually, like honestly, basic statistics because it's so easy to just kind of forget where all this stuff comes from. Um, in my current work, I don't actually do, unfortunately, a lot of. Excuse me. Oh man. I unfortunately don't do as much statistics and data science as I would like. My current project that I think is the most worthwhile is actually a natural language processing project, and it's got unsupervised learning, and it's super cool. It's like a data set that like nobody really actually like no one uses. So it's just a wide open field in terms of potential. The problem is that when you start doing natural language processing, you don't always use the things that like other data scientists would use. So like I don't use a whole lot of statistics in my day-to-day work. I don't do a lot of this is unsupervised learning, so I don't have to review things like classification and that kind of stuff. So yeah, so I've been going over. I tried to go relearn by using some Coursera classes and also the Intro to Statistical Learning textbook, which is a great book. Uh, and even just on the side, I'm starting to like watch the videos that go along with it. The problem is that I find those books basically or resources basically assume that you have already mastered like statistics and you know exactly when to apply everything, which I feel like is like something that people kind of take for granted, is like that's not actually very true. um, so sometimes you can like actually I was just asked a question in a job interview, which was like how do you handle an imbalanced data class or classification problem, and I was like, oh cool, well you can synthetically minority oversample, or you can penalize the majority class so that you sample from the majority class less often. The thing is, especially with the synthetic minority oversampling technique, maybe that's not the best thing to do. And also, like, it's super computationally intensive to do that. And I speak from experience in doing this because, like, in using, there's a library in Python to do SMO. It just takes forever because it, like, kind of fakes different data or simulates data and then tries to even it out so that you end up, like, everything being over equally balanced. And by doing that, like, it kind of may emphasize we'd kind of seen this with bootstrapping actually. It may like artificially inflate the differences between different things. So like there could be you might end up finding like, oh yeah, well these two populations are actually different, but then in reality, like depending on the significance of that difference, it's like the actual practical significance, not the statistical significance. It's like not worth pursuing. It's kind of odd. But yeah, so the stuff I'm doing now is basically right now it's like an intro stats class because it's like, oh, let me review like a lot of the base theory behind this, and then I can dive into like applying statistical learning to or statistics to machine learning problems and stuff. So far it's been pretty cool. I put it in the description. We're following along with Curtis. Oh man, I can't believe I forget his name still. Oh yeah, and the reason why I'm doing these accountability things, you can see her picture on the right of the monitor. This is a study with Tina Huang. She is a data scientist at Fang, and she does these like 4 times a week, which is honestly, I don't know how you do that. Very impressed. And she does these to kind of keep herself accountable on studying different things. So, what was it? The person I'm following along with is Curtis Miller. He at the time was a lecturer at the University of Utah, and he shared some of the resources on the playlist that's shared in the description, and I'm just following along there. So I will soon like click in. I am on multivariate probability. There's only like 20 something minutes left. And I guess to briefly explain what was going on today, I actually wanted to be on at like 3:30, and I have been in contact with a hiring manager at Stanford, Stanford Health, and I have no idea what's going on there. But the long and short of it is, we were supposed to have a phone screening today, and that was 8 minutes ago, and I never got a link. And it's been about a month of communicating off and on with this person. So the next time they reach out to me, I'm just going to say, like, I'm super not interested. This is like not a professionally run organization. I looked at our email thread, and it's like I can go anywhere from 3 to like 13 days without hearing from that person. So I'm just like, all right, clearly you're not actually looking to hire people, or the org is so crazy disorganized that like I wouldn't want to work there. It doesn't help that I looked at Levels and Glassdoor for the salary expectations, and I think they'll actually pay less than what I'm being paid now. So definitely not interested. Yeah. So with that, I'm going to jump into this class, interest stats multivariate probability. Once I find my pen. Maybe I will use a different pen today. Let's see if this will write. Cool. We're using a different pen today. Let's just get started. And then I'll probably stream for like an hour 20. Maybe try to do 2 lectures. And then, yeah, then I'll probably maybe do a little bit of stretching and go prepare some dinner. So yeah, thanks for coming along, and I'll check in with y'all soon, later, or, whenever. Okay, so I forgot. I actually had been doing this the last stream, so we're jumping straight into an example, and I'm going to basically mute myself while he goes through this example. He's actually explaining how 2 random variables are considered independent. So that's cool. Oh, right. Also, this is a new channel because I wanted to separate the study sessions from my normal stream, or my normal, what's it called, channel. So yeah, I'm starting to split out. So it's study session, data science, and photography and travel. So yeah, anyway, all right. Enough distractions. Let's get to it. It's pretty funny. He's getting to the point where, so right now we've been dealing with two random variables, and now he's generalizing to n random variables. And of course, like when you start doing that, the formula goes nuts. So he said like, "Yep, I'm not gonna like writing down this formula." Or while he's working through this formula, I just got a reply back from that hiring manager saying, "Yeah, none of these times work for me." I'm like, "You're 20 minutes late to the time you told me to go to." Um, and yeah, I'm just like, I'm not super not interested. Cool. So he was walking through where the generalization of the um, binomial to the multinomial distribution comes from, and partly it's because like before it was like an n choose two, now it's like an n choose however many variables you have. So he's just writing it out and then kind of took a bunch of shortcuts. Honestly, during that time, I was like letting some people know what happened with this like Stanford healthcare hiring manager. So we're about to roll into the next video, which looks like it's bivariate distributions. Let's see. Here we go. It's going to go to the next. Oh, yeah. So the next one, yep, bivariate expectation. So that is this link. I don't know. I think I sent that to the wrong chat window. Here we go. There's going to be this one, link. Oh, cool. And I get to figure out why my chat is in the wrong spot. Here we go. Thank you for your patience with this. I think that this isn't always the nicest. Oh, that's not what I wanted. This isn't always the nicest UI for streaming. Okay, cool. That looks better. Yeah. Okay. So that's the video I'm on right now, and then I'm gonna start playing. So yeah, Bivariate Expectation. So that's gonna be a new chapter, new section. And so an update, he's going through and explaining like with the bivariate expectation, how does this change your like expected value calculations? And remember that like with the univariate, it was like the function h of x times the probability of getting the the x. Um, so it's basically the same. In the discrete case, you're summing over x and y. So h of function x and y, probability x and y. And then for the continuous case, it's a double integral. So with that being said, he's now actually going through a specific example of computing the expected value of x times y. So he's just writing everything out now. And the particular example he's working through is like the a while ago we talked about rolling a die and flipping a coin at the same time, and getting like 1 through 6 or heads or tails. So like those are obviously independent events, and now it's like, well, what is the expected value of getting of this like particular die roll and flip a coin? He's doing this thing where he's like, oh, when we rearrange and simplify, we can just like rewrite the entire thing as this, and then you just erase the whole function. And I actually kind of hate it when people do that because like I had a professor who would do this with the chalkboard or the whiteboard, and it just drove me crazy. And it was like, we have to rewrite everything, right? Like it's not as easy as just like removing a subscript. We have to like rewrite the entire thing for the notes to make sense. So yeah. he's still there was another example with the pounds of mixed nuts. So it was like almonds, cashews, and peanuts. Now he's redoing that to try to find the bivariate expectation. All right, now some R code explaining. We went through all this example. How does it work in R? Super easy. It's like 5 characters. Yeah. Now, one measure of the relationship between two random variables is covariance. So we're going back to like actual lecture. This is pretty interesting. He's going over covariance, which I think I'd said before I went on mute. And one of the things to point out with the covariance is that it actually has units, so it's kind of weird, right? So he was saying like if your variables are like height and weight, that would mean that your covariance has units of like kilograms meters, which is super weird. So to get a unit less, if you start scaling inside the your units, you end up with like pretty like your covariance changes. So he said the way to get around this is to actually adapt it so it's unitless, and then that becomes the correlation. Um, there's definitely things I've used before in trying to find relationships between variables. And he's going over some of the like the basics of correlation. I'm like, oh yeah, I remember this stuff. So if you don't know, correlation is scaled, right? So it goes between -1 and 1. And one of the things he points out is that some people actually, because it's between -1 and 1, and therefore the absolute value is between 0 and 1, some people actually report correlation as a percentage. I have never seen that before, and he hates it. And I was like, yeah, I have like a visceral reaction to that. Like correlation shouldn't be a percentage. It's just from -1 to 1. And the thing is like the magnitude between 0 and 1 tells you how basically how uh, related your variables are. And if it's 0, there's like implied that there's no relationship. And then the direction implies like, for increase in one unit of x, you get like a minus in the other, or increase in one, and then does it also increase the other variable, or minus, et cetera, et cetera. So one of the things I actually kind of forgot is he's pointing out that like just because your correlation is 0, that doesn't mean that there's no relationship. It just means that there's no linear relationship that isn't showing up in the correlation. And I kind of completely forgot that part, so it was good to actually hear that. So I'm gonna write that down. All right, so he's going through a interesting exercise. So he's saying that we've got sample space with point UV bounded by, and then there's four coordinates. So he said, given this, compute the covariance. So we're going through like I guess a real exercise, a real toy exercise, trying to find if U and V are independent. Um, yeah, I think just I have a quick look. The points are not square or not. They're not rectangular. So I'm kind of like, I don't know if this is going to be. I don't think this is going to be independent, but we'll see. We're walking through. Very cool. So walking through this example, you get the covariance and the correlation being zero. So you would think like, oh, well, maybe they are independent, and it turns out, like he points out, it's not, because when you actually do the marginal calculation, it doesn't match what your actual state space is. So the example was like if you're at point one for one coordinate, you're locked into one of two results. It's like minus one or positive one on the plot. But if you actually look at the marginal probability, it's supposed to be 1/8. So since those don't match up, it means that even though the correlation covariance is zero between the two variables, they're not actually independent because you've locked into one thing. So it's a good example of like there is a relationship, it's just not linear. So it was cool. It was actually a really simple example. Nice to see it done out. All right, so he's going through basically R right now. So yeah, it looks like there might be one pretty long walkthrough of a binomial distribution, but like I think it's gonna really quickly start going into R. I can't help but feel like there's a typo in what he wrote. I think there should be like a y instead of an x or x1. Hmm. I mean, I'm not sure if it really matters. Like once we're gonna use code for this because it obviously is like way too complicated to keep writing out by hand every single time. So it's interesting. He's saying with the bivariate normal, anytime you take a 2D slice out of it, you end up with a normal distribution. Just like, oh, this seems really obvious. But now he's going through the exact formula that is kind of explaining stuff, and it is kind of cool. Yeah. it's pretty cool. He just went through an example where the two variables are actually they're both normal distributions for themselves, but it actually demonstrated that like it ends up affecting when one is outside the normal, you end up demonstrating like a regression to the mean, and partly because like there was a correlation factor that was provided as part of the problem. Um, so yeah. The example was like father 78 inches tall. The average is 69.2. How tall is the son going to be with a 95% confidence interval? Um, so yeah, like working all this stuff through, it was like, oh, well, it looks like his son will actually follow a normal distribution centered around 72.2. So he'll be taller than average, but not as tall as his father. And that because of the correlation, the standard deviation is actually tighter as well. So yeah, and now he's working through like trying to find the actual um, range that will end up range of inches for the height. So yeah, cool. Yeah. So now he's going through some R code to calculate it, and then this is going to be the end of this particular lecture. I was thinking of watching another one because, like, since I'm watching on 1.5 times speed, another lecture would put me at like an hour and 40 minutes total. But it is almost 6, and I am getting hungry, and we've been streaming for about an hour and a half. So I think this is a good time to take a break. My watch already told me it's time to go take some steps. So I think I'm gonna go go make dinner, and then I will probably watch 2 more lectures to keep working through this. And I feel like I'm in the mood for extra classes today, and I kind of want to like go and start doing some SQL because I'm a little antsy to do like actual like technical data science, like hands-on keyboard data science stuff. Um, so yeah, this is I was also testing this like new stream channel, and we'll see how this goes. It seems a little wonky, if I'm completely honest. Like on YouTube, it doesn't show that I'm streaming, but it looks like everything seems to be working. Like I don't know, super weird. Yeah, so more homework for me to figure out. But yeah, till next time. My name is Aaron. I am a data scientist at government, and I am doing these study accountability streams twice a week, Tuesday, Thursday, and basically just trying to figure out what stuff to study to like be a better data scientist. If there's stuff that you want studying, if you want to study and want an accountability buddy for, feel free to message me. My contact info is basically there. I think that still needs to be updated. And the inspiration for this was Tina Huang's channel. So she seems like a cool data scientist. Yeah, I hope to see y'all at least on Tuesday. And if not, hopefully soon. All right, I'll see you later. Bye.